Greetings everyone. Today we are once again here with our another webinar on reservoir management, and today the speaker for the session is Dr. For the speaker for the session is Rohit Kumar sir, who is a senior reservoir engineer, and we will be starting this session in a minute. And at the end, there we will be sharing the feedback form, so you have to fill that for the certificate. And those who have any query or question related this session can ask and interact with the speaker at the end after the session is just end here. So we will start the session. Over to you, sir.
Okay, so good evening, everyone. Good afternoon, and I don't know the time frame and time zone which you have entered. Is my voice audible to all?
Yes.
Just can anyone write it down in the uh, Zoom meeting and say that everyone is audible?
Yes, sir, it is audible.
Okay, okay, so we are good to go. Okay, so yeah, good evening, and my name is Rohit Kumar, and I'm a graduate engineer, bachelor's and master's from a university called ISM Dhanbad, and I passed out in the year 2013-14. And since then, I have been into oil industry for close to 7, 8 odd years. So I have worked in the field of Nigeria, and 6 diversified years I have been there. So, and in these 6 long years, I have been into one of the widest, the diversified reservoirs of all, like sandstone kind of a character, and some of the complex reservoirs that we have seen and developed in this 7, 8 odd years. Last year, I came back to India, and it was a tough time for COVID and all for everyone. And since then, I'm currently working with Focus Energy Limited as a senior reservoir engineer. And in this 7 years, I have had experience of artificial lift also and development of reservoir with the help of various artificial lift mechanisms. So in this in this short session, I will be briefing you about the reservoir management and what are all the key parameters that are there in the reservoir management. And this is like the content is based on for all the aspiring petroleum engineers who are seeking a career in reservoir and domain in the oil and gas industry. So, I'd like to welcome you all to the industry. Now the oil prices are being picking up, and we all seems that maybe in the current future or so, there will be huge requirement that is coming on. So, and to be very frank, this particular domain is requires one of the highly intellectual skills and highly intellectual skills that some of you might be working currently in the oil and gas industry. So they might be aware of the challenges and the loopholes that are there and the technological advancement that is going on time and again. So with this short introduction, I will continue my session. So, what are all there in the reservoir life journey? So, the journey of a reservoir management starts with something of called as a discovery. So, we are into oil and gas business, and it takes a very quantum amount of intelligence to collect those data and analyze those data and see where the oil and gas is. It's a deposition of the environment, and the crude oil and the natural gas has been deposited a million years ago with the geological strata being formed, the traps and the folds and the structures. So to analyze all those things, the first preliminary aspects of a reservoir life journey is the discovery that we intend to do with our geophysicists, geologists, and the team of reservoir engineers. So the what I wanted to emphasize here is that it's a full journey of a lifetime. You have to develop the energy from the beginning to the end. So a reservoir engineer is like a doctor who is treating his patient as a body. And the, what are the challenges? Suppose in the early stage of lifetime, you are very young, you are fit, and you are ready to do your work and quite fit. So discovery, delineation, and development part is what I consider up to the primary stage is your youth time, and where you have the natural tendency to develop all your reservoir, and you are very energetic to flow and the movement of flow. So the time when you have the discovery to the time of exploration and to the time of abandonment, the whole cycle takes into this prospect. So initial starts is under yellow circle exploration. Then we move into discovery. Discovery part after the discovery, it's into delineation. Like you tend to develop how many of the wells that you're going to drill. What are the optimum number of the wells that needs to be drilled? Now placement of the well, whether you are going with a vertical well or a horizontal well or a deviated well, how many faults that you are going to encounter, what are the, suppose you are near to oil water contact, how you're going to develop that, what are the challenges that you have to take in water handling if you are into high gas or reservoirs with a very thin oil and gas cap rim, so how will you develop that? So all those small to a very big complex strategy determines the reservoir life journey. And there is always a team playing into it. So reservoir management always involves a full set of team, which involves including every aspect of our oil and gas professionals like geophysicists, geologists, reservoir engineers, petroleum engineers, completions engineers, workover engineers, then your petrophysicists, then your team of finance, then your team of pipeline designing, facilities designing, then your team of security personnel as well, then your team of like government professionals whom you take your permissions with, auditor generals and all. I mean, you get a full set of team responsibility, and it requires a huge managerial role. So, like I was saying, what is the reservoir management? It's an integration of available resources. Like I was saying, resources doesn't mean that you have just the oil and gas sector and you need to develop it. It's first and foremost thing is humans. So, like I was saying, a geologist is involved, a geophysicist is involved. Now, to get all those people and a reservoir engineer on the same page, you have to get to a theory where everyone has to abide by the same rules and conditions. Now, for that case, we analyze that in the exploratory aspects. Okay, what are the contingent resources that we are looking at? What are the probable aspects we are looking at? What are the proven aspects that we are looking at? So all these analysis goes into picture. Then there is a financial implication that is going to run. Oil and gas business involves quite a handsome number of money initially itself, and the success ratio is 90 to 10. Even that is, I mean, like a very good number. 95 is the failure ratio, and 5% is the success ratio. So in that margin of error, we plays into the picture. There is a huge technological advancement that plays, and research and development team has been performing since the first discovery of oil since 1800s, 1850s time, and since then, Schlumberger, Weatherford, Baker, service companies have flooded this full reservoir management, and they have provided immense technological development. N number of tools has been developed to get you a full picture of how your reservoirs look like. And definitely the data that you are handling is one of, I mean, like huge. You get every second's data, every minute data, and every meter data to a very minute details. Like you have in drilling, you have so many mud logs. Then in logging, you have so many logs, sonic, porosity, density, neutron, I mean caliper, n number of data that you are handling. And it's an integration of all these resources. what your whole objective of studying a reservoir management is, you get your oil and gas which is there in your downhole conditions to the surface conditions optimally. So it is no longer enough to just manage the reservoir itself, but manage in such a way that value is added to the company asset. So the value addition involvement is always crucial role, and that is playing into the picture that it involves so many number of available resources integrated. So, like I was saying, it's an integrated and interdisciplinary approach. Now, already I have mentioned the resources part. In terms of human resources, there is an exploratory side, like geophysicists, geologists, they are going to initial stages of exploration. Then once they identify it, they characterize into a reservoir that okay, we have this number of reserves that we are looking at initially. Now, are we ready to go and drill and see if the flow can be achievable or not? Now, in that stage, a reservoir engineer, since the time discovery happened, their role has been assigned. The role involves NDT sampling, all those fluid sampling, and you take the data and analyze into your PDT lab. And in that set of criteria, we try to analyze so many things like how efficiently our oil and gas or three-phase flow is going to take, uh, like its full phase of flow into the like surface conditions, and from surface to the facility side also. Suppose you have got your plant installed at, let's say, 15 kilometer or 20 odd kilometers from your well location. So how efficiently your fluid, three-phase fluid is going to transfer from its surface to the facility and to the customer's end as well. So you have to minimize and you have to optimize everything. So that particular thing involves resources involvement, geoscience involvement. Means identification of each layer. Identification of what are the characteristics that can be confined together for characterization of a reservoir. Let's say if we are defining a fluid model, what are all those parameters from the petrophysicist side to calibrate it into a one set of a reservoir. Then characterization, we classify into each sectors, like we distribute into species, we populate our physical properties that are getting from logs, and we build a geological model. So, all these blue arrow that is coming together, it's coming into a reservoir domain. Petrophysicists, petrophysicists, what they are doing is that they are, taking the logs, scorings, and then they are putting all those input data into the uh, reservoir domain and characterizing it whether the fluid flow can be possible or not. The same way, suppose your well is flown for certain period of time from one set of a reservoir, that becomes your history. So production people, they have the performance data as well. So that also we take into the picture. We do history matching. We characterize our reservoir based on the history. We do the forecasting. Okay, suppose now for a certain period of time with let's say four number of wells, we have achieved certain amount of production. Now, what will be the optimum production in certain years? Let's say 10 years down the line with 5 to 10 number of addition of more wells. So that could be the question your management would ask you, and you have to justify it with a full set of analysis. So this all these data plus you are taking exploratory, wells, and you are carrying a PVT analysis. Standardized whole lab analysis can be performed, and all those set of data, each individual data goes into picture to define the reservoirs and the flow characteristics. Placement of the wells, defining the reservoir, putting petrophysical properties, putting the production data, matching your history with the lab data, make all this full-fledged of flow into a dynamic reservoir modeling part. So there is a set of data which is always called a static model. You populate your property, you get all the set of data, So what distinguishes between a static model and a dynamic model is all those properties which changes with time. Suppose your relative permeability graph, the two-phase flow that is going to change with time. So, porosity data, there is a time-lapse porosity. I mean, your porosity also changes with time. So all these data which changes with time gets into picture. So populating of any property into static model to its phase into a dynamic model gets into a reservoir management side. So getting after that, you have so many things that it's all just an integration process that I'm talking about. What are the tools that you are having? You are having your material balance techniques. We all have studied in our high schools that what is a material balance. What it's just a work on the principle of conservation of mass. So whatever there is inside, you have taken out something, left is inside is the same thing. You are just taking all those conversion factors and just putting it aside. So material balance is there. Then there is the decline curve analysis. So all these things is there in your picture when you do your reservoir simulation studies. So in here, you can see the reservoir simulation. You can place your single well, and you can place your cross section. You define sector wise and you define field wise analysis. What is the contribution that you are giving it from the reservoir management side? You are initially in the short-term reservoir management, you are planning your depletion strategies, whether your reservoir is going to be depleted. So suppose if it is going to be depleted, your pressure is declining, your like fluid, you are not able to handle efficiently from the downhole, so it's not wellbore condition, it's not lifting it to the surface. So any artificial lift mechanism, you can install it there. If your well is going to cut water cut, which is now increasing with time, what is going to happen? Can you handle all these things by the same way that it is there, or you have to install any sort of an artificial lift to maintain your production as well, and you maintain your reservoir management side. So all these plannings, is there any completion change that you have to take, whether you want to complete into a two-zone commingle production or you just want to perforate each zone as well. These all plannings goes into reservoir management side. Their long-term development planning is that suppose you have recovered to your primary recovery. Now, what are the secondary recovery mechanisms that you can go? Whether when like water flooding you want to introduce, when like water injection you can plan, water disposal wells you can drill, or maybe like gas flooding is there. I mean like in situ floodings are there. Then there are various chemical injections. Suppose some of the reservoirs are waxy crude and you get to involve into hot water treatment of those waxy foods. All those small planning and all those individual planning is your contribution from the management side, and this and that is the reason we optimize our project and we get our end product that is an optimized development plan, and you have your production profiles, you have your reserves, and you have your recovery optimization. So moving ahead, this is why we require reservoir management to maximize your profit from a reservoir. I mean, like by recovering, optimizing your recovery, you have suppose 100 million barrel of crude oil. So any geophysicist would argue with you, give me 100%. And you say, no, I can give you just 20%. There will be initially argument with the CFO, and you will be saying that, oh, this guy is not an efficient reservoir engineer. We will be requiring some more efficient one. So you want to maximize your profit, and this is how any business organization works. It's all working for a monetary prospect, and how efficiently you can work, minimize your capital expenditure and operating expenditure, maximize your profit. But that depends upon the crude oil situation as well. But leave aside that part, look at the planning in picture. You need optimum reservoir exploitation. That is the technical side you can do possibly. And you can unlock what are the new potentials, some infill wells which are not drilled, and some areas which have not been covered, you can easily target those and build it and get your company achievable those prospects that were not being targeted earlier. So now this added value to the company side from the management is what a reservoir engineer and the reservoir management side is looking at, whether it is in the context of midstream, upstream, or the downstream business. So upstream is you can get into like sectors like exploratory or development part. The midstream is like the transportation, and the downstream is the facility side. So that is all they are looking at. But I mean, like overall, the reservoir management plays into picture of every prospects as well. So these days the term that is used is WRFM or WFM. This is well reservoir facility management or well facility management is in there, or an integrated reservoir management IRM kind of a wording is being used in the industry. So this is what I mean like is there. You know, it's an integrated approach of a reservoir with a well, with the facilities and to the surface side. So necessary steps in the reservoir management is, identification of, sorry, sorry, yeah. So this necessary step in the reservoir management is first, like I was saying, identification of reservoir in the field and their properties. It's very simple. You just have to identify the reservoirs from the field. Some might be depleted, some might be high water cut, some might be pressure-wise different connections, some might be like channel sand, some might be a like bar, some might be pinch out, some might be like a sandstone from the siltstone, or from some might be shaly sand. Identify all those reservoirs that is a waxy crude. I mean, like even in the crude also you can distinguish like highly volatile or near condensate or some condensate banking kind of a reservoir that is there. So there are various classifications that is there. Identify all those reservoirs and try to develop. Now, deduce past and predict future reservoir performance. What does that mean? You have a past history of a reservoir management. So there is suppose some reservoir you have like n number of wells that is been drilled, and from that wells you are predicting your future performance. Now minimize unnecessary drilling wells. One well in India costs like 25 crores. I don't know now like costing has been reduced or something like that, but more or less it's like that amount of money. So your job is to save those unnecessary wells that is there. And believe me, 25 crore is a very huge amount in terms of any company that is looking that you are looking at. If it is a deep water and the deep water prospect wells and into a deep water horizontal, that makes it even more costly, maybe 4 or 5 times. So 100 crores of your of the worth money you can save it economically. So any company would be happy with you. So it's a, like I was saying, it's an integration, it's a synergy, and it's a support. So these all integrated and interdisciplinary efforts take into picture. So this all things is all what I have mentioned. A basketball team and a relay team. Okay, so multidisciplinary professionals are working as a basketball team. They are coordination. Basketball there is a very hands-on eye coordination with the players' foot movement. They throw the basket and then you have to catch at the right hand and throw it into the basket. So it's not a relay kind of thing when one person is running and other person is just taking the relay part and then forward. So integrated effort, and all of them are working simultaneously and together so that they can achieve a certain amount of goal. So now this is the elements of a reservoir management, like reservoir knowledge. Firstly, you have to know what is a reservoir, how efficiently and what are the data that is getting to the of a reservoir. Like I was saying, there is so much of a reservoir that is there. Even in the each species, there is a different property that can be populated. Now, I'll mention you one of my Nigeria examples. Within like 7 meter of a sand, every meter of the like in the top section, that top sandstone was declining with a different pressure regime, and the second layer were declining in a different pressure regime. So within the same reservoir, although the fluid were different, I mean like the fluid properties were the same, even we carried out so many PVT samples, but then the pressure decline was different. But then some of the reservoirs were like even in the 7 to 8 years down the line, even 1 psi was not reduced. I mean, 1 psi was reduced. So it was so much strong aquifer reservoir. So reservoir wise, each reservoir is different from other, and you have to have the knowledge of and understanding to develop every reservoir optimizingly. Now that involves like geology. You have to have your geological understanding very well. Now, you know, rocks and fluid properties, what are the three-phase, two-phase flow equations that are being used. There are so many industry equations and so many, I mean, like vertical flow. You have different, like, petroleum expert 5, petroleum expert 2, Basker's equations for viscosity matching. So there are so many equations there. In IPRs, you have so many like Vogel and then Darcy, then and like other equations, you know. Uh, so all these small properties that you have to match in terms of making your reservoir flow and reservoir flow characteristics defined. And you basically what we are trying to do is that we are analyzing it from the surface, and there is a natural thing that is going out at a 4,000, 5,000 kilometer, 4 kilometer down the line at the download condition. So we are just replicating in our software, and we are visualizing all those things. Now, visualization part involves matching as closely as it is in our reservoir. So it is not like that you are putting some garbage data into it and you are taking some garbage in out. So as closely we are our reservoir, we can go, we can replicate it so that history and the forecast is realistic to what is there. We can't achieve actually in 100% I mean like that, but certainly you can try as much as you can. So like I was saying, its reservoir knowledge includes the rock physics properties like lithology, like porosity, permeability data, strengths, and then fluid characteristics, fluid types. Then there, rock fluid properties. What is wettability? What is the impact of wettability? How, I mean, like effective permeability and relative permeability plays into picture and defining your rock physics function into your dynamic simulation. So these all are the things, and your capillary pressure it takes into picture, and flow modeling is there in that part. So oil water contact, how effectively you have managed your capillary. So these are the tools that you have, and the knowledge that you have to possess so that your dynamic reservoir model is, I mean, like realistic to what is happening in the actual reservoir context. So I mean, like this is something which is related to, I mean, like I have just figured it out, like the parameters, depth, pressure, and temperature. So what is the reservoir management issue that can happen? Like any particular depth, sand production might be a issue. So you have to design some sand stream down the line at that depth. So you are drilling with some I mean like a normal pressure regime. Now all of a sudden you start encountering loss circulation. So with the pressure you get different issues like overpressure, under pressure, and the normal pressure. Some kind of a scenario. Now, with that same depth and pressure issue, there can be a cementing issue. Cement failure is there. So we have serial radial log, we have usage logs, and we have different logs that can be identified for to check the cement integrity with the casings and with the formations as well. So like that, this is the I have just jotted down the parameters and the issues that is related to that, and these all are the regular routine issues that is faced from the industry side. So I have just tried to figure it out. Rock physics, rock properties, you have mythology, you have sandstone, you have shale, saliness, and like well spacing, packer set point, flow units. So it's all the reservoir management side that is in place. With the integration of rock, lithology, porosity, permeability, and strength, we define our all these things scenario. And the results, then facility and the flow rate takes into picture and defining of all these things. Now, after that, fluid properties, different number of different set of fluid properties are there, like condensate, dry gas, wet gas, or black oil, degree quality of oil, flow assurance issues. So all these kind of scenarios are there. The same way rock physics functions also. You have wettability, you have relative permeability and capillary pressure. Now, the identifying of each zone, like advancement of waterfront. Let's say you have not defined the relative permeability property, and the waterfront, is taking place more in your well than you are expecting it. So somewhere, some down the line, your relative probability and wettability is not correctly modeled. So you have to change your Fourier coefficient. Basically, what you have to do is that you have to adjust your two-phase graphs so that it replicates to your actual conditions. So these are all the tools and the tool parameters that we can put and model the reservoir and the dynamic model so that it replicates to our actual conditions. In the same way, energy is like is that you can model your water production, water drive with a very high aquifer water strength water drive, or with a low aquifer strength water drive. In the two scenarios, maybe your water reporting is not there at the surface. Like in Focus, I was mentioning, initially water reporting was not properly being done, and when nobody has focused on that person, then I came and I initialized that for me reporting of water is very important, so that in material balance I can match it up very perfectly. So each aspects of water is involved. Even a single barrel is important for me in terms of gas context. So, the reservoir knowledge involves integration knowledge of all these things. Firstly, geology, then recovery mechanism, then fluid, rock, fluid flow, and the past performance. So now, what are the deductions from the reservoir knowledge? Basically, it's a microscopic nature of the reservoir. A macroscopic nature means you have to get involved into the minute details of the reservoir, like each and every aspect in terms of fluid, in terms of size, in terms of variability. Now, even in the core, suppose porosity also in lab you have mentioned, there are two sets of porosity as well and permeability as well. So whether your RCA data you have correctly measured it or not, whether they have carried out carried out the cutting sample perfectly or not, whether your course has been stored or not, the properties which you are taking has been populated and writing down in the data storage or not. In suppose after all this context, what are the chances that your data and your reliability of data is replicating your actual dynamic conditions? So you have to understand the macroscopic nature as well and the microscopic nature as well, like reservoir morphology, porosity, fluid saturation, matrix content, the capillary pressure relationship. It's all those each and individual and other issues can happen. So there are certain situations which you can't avoid. So that each and aspects that is going to impact your reservoir and impact your reservoir performance that you have to know. So the understanding of macroscopic nature of the reservoir in the same way understanding of microscopic level of the reservoir. You have to set and get the idea of a reservoir history as well. Now, how many number of these? It's all normal routine job for a dynamic reservoir model, like drilled wells, how many is there, whether you have entered the right specific locations like X, Y, Z, and the coordinates that is there. I mean, like even if you miss a certain degree and certain inclination, also you are not efficiently developing it. So basically, it's a very major issue, but it's a very minute thing that I'm telling you. It's like something which you have to be very specific in terms of development and in terms of a particular reservoir. So you have to deal with certain data that is there, plus the right knowledge. And the same way management of the environment, like you have to deal with the CSR activities, the corporate, social, and economic factor like lease. Maybe you are planning something, your lease are going to expire. You have to drill early. You have to drill maybe plan some more addition of wells with the time. Maybe you have to understand and take safety measurement like in any completions and completion related forum. You have to get an IWCF kind of a certificate. Same with drilling and safety regulations of takes place also, and you have to get the deep water training as well, get into the subsea areas as well. So there are various aspects that is there, and you have to deal with that as well. Now, in terms of availability of capital, certainly this is one of the biggest thing that takes into picture and plays a major role with this fluctuation in the oil market. It's always impact quite a bit. The same way, management of the environment may place constraint on actions that may be taken in the reservoir management, but also provide options and opportunities for creating new initiatives. I mean, like, uh, I'll give you a brief example about how we did it. I mean, in the initial context of me joining in the Nigeria and development of a reservoir, we were like looking at installation of gas lifts into all our high water sectors. What we did is that we were having various reservoirs and we were trying to develop all those things. What we did is that we take our own gas lift gas and uh, drill some of the wells with just for high gas intake. And what we do is that we installed the compressors at on site and used our own gas lift gas and then for the lifting of high water sectors. So this was the initiative which we took into back then in 2013-14 period, and then we tried to develop it for 6-7 long years. The same way, modeling and installation of different kind of artificial lift method is you can take it and install at any particular set of time and see the performance of different kind of a scenario. So there is always a room of initiatives that can be taken place. So, and one more thing that I can tell you is that we have also modeled one of the reservoir. I mean, like, not, we have developed an equation basically that can optimize the actual amount of drain hole that is to be drilled. Horizontal, when you drill, there are various sections like landing to the drain hole side. So you don't need to drill, and in horizontal, it gets very costly. So in Nigeria, the equations were very familiar. We modeled it and then we tried to match it up. So that part, it was very good and we modeled it very correctly to our dynamic simulations. You don't have to unnecessarily drill. Let's say you can suppose your 100 meter of a drain hole can suffice 300 meter of a drain hole production. So why to drill another 200 meters of a drain hole? So, like there's kind of an initiatives that you can take. The same way initiatives can be taken in terms of development of the technology, like in Slumber, Weatherford, Baker, and in operator company also there are initiatives that is going on and technological actions that it's not limited to just by like controlling their course of action. It also means extent of the knowledge that can be gained in terms of the reservoir. What we are investing in technology is to gain the knowledge that we are having about the reservoir and replicate it and see from the past that how in future we can forecast it. So technological advancement means method of acquiring data. Earlier conventional cores, sidewall coring were quite familiar earlier, but now these days industries have discarded sidewall cores because the data which has been there from the sidewall core is not useful at all. So now we move to conventional coring, although it is very costly compared to sidewall, but the data itself is not of no use. So mm, it's just a basic example. Like and in earlier case, there were like different set of tools that were used in 10 years down the line before. Now the tools has changed and we get a highly advanced set of tools that is there in the industry. So technology itself is taking into picture. Now these digitalization, with the digitalization, everything is been set in the recorded into the cloud format, and even the dynamic simulation modeling is done in the cloud, and you know there is a search engine that is running at the back end, and in front end you are just visualizing the thing which is there for your part. So this whole set of a technological toolbox involved like geophysics, 2D, 3D, even now is a 4D system is involved. The same way geology, geophysics, production modeling, and production engineering and reservoir engineering. These are all the tools that is there in reservoir engineering. Yeah, I have just written out log analysis, the transient test like the pressure transient and the rate transient analysis that we do, PTS and RTS. You might be familiar with the Blessing game, the Agarwal Gardner, and McKinsey kind of a type curves, which is model for the flow gas transient analysis. Same way, there are pressure transient analysis. So, well testing, it's a very particular thing that can be done, and regularly the tools and the set of tools that is there for the advancement is being developed. The same way, material balance, how is it being done? Decline curves, now reservoir simulation, pure technology, core analysis. So, these are all the technological toolbox that is there. And we have to play in each part and try to replicate our geological model, dynamic geological model to the exact conditions that is there. So with this, I would like to take the end of this session, and I would like to welcome your questions and your feedback with our team. So over